working with a unit on quadratic equations. We have factored quadratic equations to find their solution, and we've also solved quadratic equations by taking the square root of both sides. The problem with those two methods is they only work in certain situations. You can only solve by factoring if the equation is something you can factor. You can only take the square root of both sides to solve it if you can take the square root of that left side. So they don't work for everything. What we're going to do today is learn the completing the square method, which will work for every single quadratic equation. Our goal here, there's our goal right there, is to make a perfect square so that we can take the square root of both sides. All right, so here what I've done is I've taken some binomials here, so right here, I've taken some binomials and I've squared them. So these are all the perfect squares that we would like to see on the left side. So what do they look like when we multiply them out? So x plus 3 squared, you can see I multiplied it out and got x squared plus 6x plus 9. Same thing with the x minus 10 squared. You see it multiplied out over here. And then the last one, you can see multiplied out here. So let's look and see what they all have in common. They all begin here with an x squared. Let's see if I can pull up a highlighter or something on that. And so they all begin with the x squared. So they all look that way. The next thing we want to observe is what happens in between the middle term and the last term. So notice that if I look at that middle coefficient 6, if I divide it by 2, 6 divided by 2 is 3, and square it, I get 9, which is the last term. If I take this, if I take negative 20 and take half of it, half of negative 20 is negative 10. When I square negative 10, I get 100. If I take half of 1, I get 1/2. And 1/2 squared is 1/4. So notice that you can calculate the constant C term, so the last term this way. You're going to take half of the middle term, B, and square the result. Square the result. So here we go. Here's just some practice doing that. So for this one, I'm going to find that last constant term right there by doing what I just said. So I'm going to take half of 6, which is 3, and then I'm going to take that 3 and square it and get 9 and put that in this spot right there. So 9 would complete the square. When I rewrite that, I'll rewrite it in just a minute. X minus 3/4 x plus what? Again, I'm going to take half of 3/4. So half of 3/4 is equal to 3/8. Then I'm going to take 3/8 and square it, and I'm going to come up with 9 over 64. And that's what I'm going to put in this spot right here. For this last one, I'm going to take half of 5. It gives me 5/2, and then I'm going to square it. So 5/2 squared is equal to 25/4, and that's what I'm going to put in right here, 25/4. Now what I want to do is I want to write these as a square, because that's what I did. It's I created a perfect square. If I factor this one here and write it in a factored form as a square, my first term is x, because x times x is going to give me the x squared, and the minus comes from right there, so there's a minus, and then 9 is going to be 3. If I multiply x minus 3 times x minus 3, I will get x squared minus 6x plus 9. On this problem here, I'm going to get, again, writing it as a square. I have an x in front, a minus second, And then I need the square root of 9/64, which is going to be 3/8. And that's the way it will factor for that. And my last one down here will be x. Again, well, these are all minuses. Minus, if this was a plus right here, it would have been a plus. But plus the square root of 25/4, which is 5/2 squared, is the way that would factor. So now we're ready to solve by completing the square, and you can see our steps up here. We're going to start off by isolating the constant term. So I'll do this down here. Isolate the constant term. So I want to move my 4 to the other side, so I'll subtract 4 and come up with that x squared minus 10x is equal to -4. The next thing I want to do is I want to complete the square, which is what I was just doing on that previous page, and then I'm going to balance the equation by adding the same thing to the other side. So I have my middle term here is a -10, so I'm going to take -10, take half of it, get -5, and then square that, and I'm going to come up with 25. So I'm going to add 25 to both sides. And that's going to leave me with x squared minus 10x plus 25 is equal to 21. So now I'm ready for step 3, which says to re-express the trinomial as a binomial squared. So I'm going to take this and I'm going to rewrite it as x minus 5 raised to the second power. So x minus 5 squared is equal to 21. Then I'm ready to solve it, because now I've got it into position where I can solve it by using the square root property. So I'm going to take the square root of both sides, and this will be a plus or minus. And in here I have the x minus 5 squared. So when I take the square root of x minus 5 squared, it leaves me with x minus 5. And over here I have plus or minus the square root of 21. So we're going to finish up by solving. So I have two situations. I have the situation where x minus 5 is equal to positive square root of 21, and then x minus 5 is equal to a negative square root of 21. Solve it by moving my 5 over, and I get 5 plus the square root of 21, and I also get 5 minus the square root of 21. So you want to go to your calculator and plug that in and come up with your decimal answers. And I have 9.58 for the first one and 42 hundredths for the second. Let's round them to the hundredths place. Then we're getting ready to do a second problem so that you can see one more time through the whole process. You might give this one a try on your own so that you can compare and see how you did and see what questions you have as you go through it. So if you want to pause, give it a try, and come back and double check with what I did. All right, so first thing I'm going to do is move the 19 over. So I'll have m squared plus 12m is equal to negative 19. Then I'm going to complete the square on the left side. So I'm going to have m squared plus 12m. I'm going to take half of 12, which is 6, and I'm going to square it and get 36. So I am going to add 36 to both sides of the equation. Once I add the 36 to both sides, I'm ready to rewrite this as a binomial squared. So do this. So that's going to put an m in the front. This time there is a plus in front of that 12. So it's a plus in my parentheses. And then the square root of 36 is 6. So 6 times 6. And then on the right side, I'm going to add those, and my goodness. So that's 29. 17 is what I'm going to come up with. once I do that, then I'm going to take the square root of both sides, so square root, square root. This will be a plus or minus in there, so this is square root of m plus 6 squared is square root of 17. So that will simplify with m plus 6, and then plus or minus the square root of 17. So we end up with two answers. And our two answers would be m plus 6 is equal to the square root of 17, and m plus 6 is equal to a negative square root of 17. So two different sides. So this is m is equal to negative 6 plus the square root of 17, and m is equal to negative 6 minus the square root of 17. And the two answers I have for that are 10 and 1200ths and 1 and 88 hundredths. All right, so give a try. I've got a few problems on the homework. If you move on down the page, you'll see what those are. All right, so I moved it on down the page for you, and there is your homework assignment. Not long, but you want to give a try at figuring those out. See you in class next time.